All right, so today we are going to solve quadratic equations using the quadratic formula. This is pretty much like the easiest way. The problem is sometimes kids have issues with order of operations. So our basic quadratic equation is ax squared plus bx plus c. And the quadratic formula is, here it is. And so we have a little song that will go with it.
Oh, yeah.
Okay, and so here's how our little song goes. I'll do it first, and then you guys can repeat after me. Ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, boys and girls, are you guys ready to do this?
Yeah.
Ready? 1, 2, 3. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so that equation is required that you get that memorized, and it needs to be memorized quick, and that's the fastest way I know how to get that in your heads. So when we have a quadratic equation, we basically have to figure out what is our a, our b, and our c. For instance, in this equation, what would my a be? My b is 5, and my c is negative 3. Notice it owns the sign in front of it. And then we substitute in. So I'm substituting x negative b with 5 plus or minus 5 squared minus 4 times 2 times negative 3 all over 2 times 2. Now, our order of operations are taking over here. So when I have that, we really should, I hate the way that they do it. Let's go here. Let's do this. Go backwards. Okay, I'm going to substitute right in here, and I'm going to do equals negative, and it's 5, plus or minus the square root of 5 squared minus 4 times 2 times negative 3 all over 2a is 2. All right, so my order of operations says I'm doing negative 5 plus or minus under the radical. 5 squared is what? 25. Now notice we have 3 numbers here with 2 negatives that have to be multiplied together. Negative 4 times 2 times negative 3. Order doesn't matter. So negative 4 times 2 is negative 8 times negative 3 is plus 24. Head in the game. Okay? Those 2 negatives are what a majority of people forget. If you have 2 negatives here, it makes a positive. Okay? All over 4. So now I've got negative 5 plus or minus the square root of 49 all over 4, which equals negative 5 plus or minus, what's the square root of 49? 7 all over 4. So when I have something like this, x equals negative 5 plus or minus 7 all over 4, that is not done. You have to simplify that down. Okay, so I'm doing negative 5 plus 7 divided by 4, or it's negative 5 minus 7 divided by 4. And that makes 2 over 4, which is 1 over 2. And this makes negative 12 over 4, which is 3. So my solution, negative 3. My solution is x equals 1/2 or negative 3. Are there any questions? Okay, pause it if you want to keep writing the note. All right, so the next thing we're going to do is we're going to do some completing the square. I want everybody to put their pencils down, and we're going to do this one time where we're just going to complete the square, talk about it, and be completely engaged up on the board. Okay, so what would I have to do to complete the square first? Yeah, we have to clear out that c, so subtract c from both sides, and then I'm left with this. What would I do next? Go on.
You find 1/2 b squared.
No, not yet. Yep.
Would you divide by 2?
Nope. Yes.
You divide all terms by a.
Right, we get rid of the lead coefficient. And so on the first terms, they're going to cross cancel ax squared over a. But on the second one, b will be left over a times x, right? So it's going to look like this. Now, what would I put in for that? What do I need to do to find that empty place for c? Yes.
You would divide by...
Divide what by?
You would divide the b over a by 2.
Uh-huh, and then?
Square.
Right. We're going to take b over a. We're going to divide it by 2, and then we have to square it. Now, doesn't that mean b over a divided by 2 over 1? And then we're going to square it, right? Or we don't divide fractions instead. What do? Right, and we have to square it, and then we have b over a, b over 2a, and it still has to be squared, which would be b squared over 4a squared. Okay? You guys with me? So what am I doing with that b squared over 4a squared? We're going to add b squared over 4a squared to both sides. We're adding b squared over 4a squared to both sides. Okay? Now, all I'm going to do here is I'm going to switch these terms. Notice I have 2 terms over here. Here's term 1, here's term 2. I'm going to switch their places. Put the second one first. Does everybody understand? Still equivalent, right? They travel with their sign. And now what can I do to the left side of the equal sign? What do we do at this point? What? Factor. So when I factor, what does this factor to? What's the root of that? What's the root of that? We know it's a perfect square trinomial. It's a b. And what's the root of that?
2a.
So we know we don't even have to check our work. It's already set up as a perfect square trinomial. We can just take the root and the root, right? You guys with me? So as I'm doing that, at the same time, in order for me to subtract these 2 over here, don't we need a common denominator? So what would I have to do? Multiply by what? 4a to both sides, to c over a. So I'm factoring on 1, and I'm multiplying by 4a. You guys with me? Chloe, you still there? Okay, so now if I'm multiplying by 4a, that would be b squared minus 4ac, and this is going to be all over 4a squared. And over here we're factoring. Are you guys with me?
Yes.
What do I do now? Can we just put it all over the same 4a squared?
No.
On this side, can we just make that all over 4a squared?
Yeah.
On the right side, right? Okay, now what would I do? We're going to root both sides, right? Okay. Now, up here on the left side, I know that when I take the square root of a square, we end up with what's inside. What would it be? Absolute value of x plus b over 2a. And on this side, can I take the square root of the numerator? On this side, can we take the square root of the... Is this a perfect square?
Yeah.
Is this a perfect square?
Yeah.
Is this?
No.
So we can't take the square root of the numerator, but we can split it. We can say the square root of the numerator over the square root of the denominator. Okay? So we're going to do that. Now, I can't take a square root out of that numerator, but in the denominator, what does it simplify to? 2a. Okay, and to lose the absolute value, we have to write plus or minus, right? And then what am I going to do?
Subtract b over 2a from both sides.
And then aren't we left with negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a? Doesn't that really equal x equals negative b plus or minus the square root of b squared minus 4ac all over 2a? So what you've just done is you have derived the quadratic formula by completing the square. I don't want you to memorize it. I want you to know how to complete the square. If you know how to complete the square, you can derive the quadratic formula. So now, let's take a minute and we're going to do it in steps so you can write it down. Okay, because you're going to be required to do this on a quiz this week. So, ax squared plus bx, what's the first step we do? We're going to subtract c, and I'm left with ax squared plus bx equals negative c. Step number 2. Divide all terms by a, and we're left with x squared
Plus bx.
b over a x equals negative c over a. Now, off on the side, somewhere away from your problem, we have to take b over a, don't we? And divide it by 2, which is really multiplying by a half, and then we square it. So it becomes b squared over 4a squared. And I'm adding that to both sides. Okay, now for the next step, I'm just going to exchange the b squared, just these two terms, I'm going to just switch their places. Right? It's equivalent. Let's switch the positions of these two terms. You with me? I mean, it's the same value, right? It's our quadratic formula. Doesn't matter. Does it matter if I do negative 2 and positive 3 or positive 3 and negative 2? Order doesn't matter. So now we can factor on the left side to x plus b over 2a squared, the quantity of x plus b over 2a squared. And over on this side, we have to have a common denominator, so we're going to multiply by 4a. So we factor x plus b over 2a equals b squared minus 4ac. We can just put it all over 4a squared. You don't have to do this in 2 steps. I probably would jump right to this. Do you understand? We don't need to write this one step here. It's the same thing. Once you know that it's all. Am I going too fast? Can you guys leave at different times? Okay. Who's your teacher? Oh, okay, go. All right, next. Okay, so what am I doing next? We're going to root both sides, and then I get the absolute value of x plus b over 2a equals the square root of b squared minus 4ac over the square root of 4a squared. Separate them. I'm going to take the root of 4a squared and lose the absolute value and add plus or minus to the opposite side. And then I'm going to subtract b over 2a from both sides. Okay, now I'm going to subtract b over 2a from both sides of the equation, and we're left with x equals negative b over 2a plus or minus b squared minus 4ac over 2a. And then we are left with x equals negative b plus or minus negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. My throat is very scratchy today.
And it's only second period.
I know. So the question is, we only divide if there's a lead coefficient, yes. And when we're deriving the formula, there's always going to be a lead coefficient because because we are just starting with the actual quadratic formula with no numbers. Okay, any other questions? Yes.
What's the difference between the quadratic formula and the quadratic equation?
Well, here's the quadratic equation.
But they both come out to the same.
Right. One is a formula, one's an equation. This is an equation, and the other is the formula. It's a formula that you can use for any quadratic equation.
How would we know to use which one on a test?
Well, you're usually going to be given something like this. It's a quadratic equation. And so they'll say round to the nearest hundredth. Now notice on this one they're saying round to the nearest hundredth. Okay, so we're going to use our quadratic formula and we're going to substitute in. What is my A, B, and C? A is? Okay, we're all doing this right now. Go. A, yeah, in your journal. A is what? 3. B is? -4, and C is? So I'm substituting in. Okay. I don't like when they don't write x equals. I'm going to expect you to write x equals. Okay? And you can just keep following the equal sign. So now I'm doing -4 plus or minus the square root of -4 squared minus 4 times 3 times -1 all over 2 times 3, which equals 4 plus or minus the square root of 16. Notice this becomes a plus 12 because you have two negatives, right? -4 times 3 times -1 all over 6, which becomes 4 plus or minus the square root of 28 over 6. Now there's a couple ways you can do this. We can do reduced radical. In this case, they're asking us to round to the nearest hundredth. I would never ask you to round to anything. Usually it would be the nearest tenth. But let's get into both of those. So if I were going to ask you for reduced radical, it would be x equals 4 plus or minus the square root of 28 over 6, right? How do I reduce that radical? So this is going to be x equals 4 plus or minus 2 rad 7 all over 6. Now, if I were reduced radical, I still could simplify this by dividing a 2 out of all 3 terms. Now, my computer, it shows us factoring, like they factor a 2 out, and then they're left with 2 plus or minus rad 7. But I sometimes just like to go like this. I can take, goes once, it goes twice, it goes 3 times. Do you understand? And so then I've got x equals, it's 2 plus or minus rad 7 all over 3. Now, that's perfectly fine if they ask you to just solve. If they don't say round to the nearest hundredth, if they say round to the nearest hundredth, you're going to have to find the square root of 7, which is between 4 and 9. So it's about 2.65 or 2.64. So this is, I'm going to do this. X equals 2 plus or minus 2.65 all over 3. So that means 2 plus 2.65 divided by 3. It was actually 2.64. All right, erase that. And then the next one is, or it could be 2 minus 2.64 divided by 3. So I end up with, this becomes 4.64 divided by 3, which is 1.54 or 1.55. So it's about 1.55. Okay, and the other one is negative 0 64 hundredths. So it ends up being, this becomes negative 0.64 divided by 3, and that becomes negative 0.21. Okay. Do you understand how to estimate down to the nearest tenth?
Yes.
Do you understand how to show it with a reduced radical?
Yes.
If they ask us if they just ask us to solve, I would stop here. Do you understand? That's as reduced as you can get with the radical. If they ask you to estimate, then you're going to have to split this. You're going to have to estimate the rad 7 and then estimate. Does that make sense?
Yeah.
Okay.
Are you able to use a calculator?
Maybe not.
Round to the nearest hundredth, you should have the two answers, the two estimated
Yes.
answers. And if it just says solve, you can
This is 2 answers, right? It's 2 plus rad 7 over 3. Because this really means, this right here means 2 plus rad 7 over 3, or it means 2 minus rad 7 over 3. You can estimate that too. Yeah.
How are we able to get the estimated one on the bottom, like 0 point?
Square root of 7. I would have, earlier today, I estimated the square root of 7. It falls between the square root of 4 and the square root of 9. This is 2 away, and this is 3. I estimated this to be about 2.6. So I was 4/10 off. I've been teaching you that all semester. Okay? I expect you to be able to use those skills. Okay. How are we doing, guys? How are you feeling about this?
I'm doing 20 of those problems for homework.
Yep.
Do you want us to do a new problem on each page? Or like
No,
each page?
no. No, you should be able to fit a couple on a page. Maybe 3. You should be able to fit like 3 or 4 on a page.
My math book is gonna suck.
Okay. Guys, we're recording. All right, you guys try the next one. Go. Go. Pause the recording, and I want you to try the next one. And let me clarify. Right now, when they ask for x-intercepts or the roots, the 2 answers you found, guys, let me clarify. I need you guys to listen when I say let me clarify. I need you to stop talking. So when they're asking for x-intercepts, and you had those 2 answers before, that's what you are finding. These 2 answers are your x-intercepts on the graph, where the parabola is crossing. Do you understand? These two answers are that. Is everybody clear on that? And we are using the quadratic formula tonight. We are not completing the square. So you're using this quadratic formula. There's no dividing out. Okay? Let's check our work. How'd you do, Nicole? Okay. So our A is -1, our B is 5, and our C is 2. We're going to substitute in. We should have -5 plus or minus 25. Notice there's two negatives, so it makes it plus 8 all over -2. So that becomes -5 plus or minus, is that 33? The square root of 33 minus all over -2. Now, 33 can't be simplified anymore. So if I were asking just for the solution, I could stop here, but it's asking us to round to the nearest tenth. So in this case, 33 falls between what perfect squares?
25 and 36.
So it falls between 25, I've got 33, and 36. Okay, so that is 6, that's 5. This is 3 digits away, and this is 8 digits. So I'm going to guesstimate that it's at about 5.7, 5.8. I think 5.8.
5.74.
Okay, 5.74. So when they use their calculators, I was 0.6 off. So about 5.74. So now what we're doing is it's -5 plus or minus 5.74 all over -2. And we are left with -5 plus 5.74 divided by 2. -2. And then this would be, or -5 minus 5.74 over -2. So this would be, what is this one? Negative, but this becomes negative 0.74 over -2. So that should, no, it should be positive. So what is it? 0.37, so 37 hundredths. Or this is negative 20.74 divided by -2. So it would be positive 10 and 37 hundredths. And they want us to round to the tenth, so I guess it would be about 10 and 4/10, or 0 and 4/10. Let's see how close we are.
No, you got, why did you get
-5 and
20?
-5 equals 20. Yeah.
-10.
Oh,
Or -20. It's -10.
you're right. -10. Let's see how close we are. So this would be -5 and 37 hundredths. Is that right?
Yeah, no.
Negative 5.4.
Positive 5.4 and
Positive, sorry. It should be positive.
then it's -0.4.
Okay, let's see what we got on my PowerPoint, how close we got to there. And that's what they got. Excellent. So if it's not in, stop. So I'm waiting on Chloe. Okay. All right, so if it's not in standard form, we have to move it to standard form. Get the 7 on the other side, and then we figure out our A, B, and C. Does that make sense? A, B, and C. Did the second time go much faster than the first? We'll stop at the discriminant, and tonight you are just practicing, and we're out, the quadratic formula.